Designing or transforming the elements into 2D or 3D objects or even animating them has never been easier. As the browser got updated, CSS3 came into action with amazing capabilities of transforming the elements into 2D or 3D objects, animating and decorating them in the best way possible. This reduced the use of heavy GIF images which were used for creating animated graphics that led to faster loading of web pages, as CSS3 animations are extremely lightweight when compared to the GIF images, and this saved a lot of resources as well. All the modern day browsers like Chrome, Opera, Mozilla, etc. show full support of CSS 2D and 3D transform techniques. In this section, we will learn about 2D and 3D transform techniques, methods, and various other transform functions. When designing a website, many times you will have to position the HTML elements or rotate them or skew or scale them horizontally or vertically to enhance the look of the website. Now in CSS there are two types of transformations, 2D transform and 3D transform. 2D shapes basically take two axes, that is x-axis and y-axis. So we will manipulate mostly the x and y axis when creating a 2D shape, whereas 3D shape takes three axes, x, y and z. So we will work with all the three axes for creating a 3D shape. Both of these transformations share similar methods and functions for creating 2D and 3D shapes. All these are considered as advanced CSS concepts which we will now learn in this section. Using the translate function, you can move any element or text from their original position to any other x, y or z coordinate without affecting other HTML components. So basically it repositions the element in horizontal or vertical directions. So let's practically implement this. I'm going to define two divisions, naming them as transform 2D and transform 3D. Applying background, padding, margin and width to the first division and paste these stylings in the second division as well. Now let's apply 2D transformation. I'm giving the transform property. This property is used whenever you want to give 2D or 3D transformation to an element. Next, I'll say translate. First, I will give only one value, say 20 pixels. Now, this is going to get applied on the x-axis, as you can see. For the y-axis, I will give the same value, that is 20 pixels. But first I will make the value of x-axis to 0 pixels. You separate both these values with a comma. You can notice the movement of the element on the y-axis. If I further change it to 40 pixels, it will start overlapping the second division. Let me give x-axis value as well. I will give 40 pixels. And you can observe how we are moving the division on a 2D plane. You can also give negative values to the translate function. If I give negative 40 pixels, then you can see the division moves on the negative x and y axis. Let me bring it back to 40 pixels. The other version and a bit longer version of giving a 2D transformation to an element is by specifying the translate x and translate y. Translate is just a shorthand for giving 2D transformation. Now for 3D transformation, we will have to give three values, that is x, y and z. Either you specify the x, y and z axis values like this, or you can use the shorthand translate 3D function. Let me give the translate 3D function and first giving two values here, 10 and 10 pixels for the X and Y axis. And now observe what happens. When I give the Z axis value, let's say 30 pixels, you can see after giving the Z axis, the element came above the 2D element. Also, I would like to mention that hierarchical order is also important. For example, if I bring this transform 3D division on top and change the y-axis value in translate 3D to 90 pixels, you can see the 2D division is now displayed above the 3D division despite not having a z-axis value. So you'll have to keep the track of hierarchical order of elements as well when applying any transformation. Let me now undo the changes and bring back to the code we were on. So what z-axis does is, instead of moving the element horizontally or vertically, it moves the element closer to you. Now many times there might be an issue of z-axis not getting applied, just like here. Even if I change the z-axis value to 50 pixels, you can see it is not getting any closer. To fix this kind of situation, CSS offers a function called perspective. This function takes a length value which defines a virtual distance between the plane of your computer screen and the HTML element on which you are applying the z-axis to. So let me add the perspective of 200 pixels here. And now you can see the 3D element comes closer as this z-axis is now getting applied perfectly, giving a 3D look. So what perspective did here is it created a virtual space of 200 pixels between the element and computer screen, and then it moves 50 pixels closer. Similarly, if I give negative value to z-axis, it will bring the element back, considering the perspective as well. So this is how you can use the translate function to move the elements from its original position. Now let's talk about relative questions. So what is a transform property, or what does it do? So transform property is used whenever you want to apply the 2D or 3D transformation to an element, as this property offers various functions like translate, rotate, scale, move, skew, etc., which can be applied on the elements. What is the translate function and why is it used? The translate function is an inbuilt function of CSS to reposition the element either in the vertical or in the horizontal direction. It is used for moving the element from its current position based on the given X and Y axis directional parameters. The third question is, what is translate Z? The translate Z is a CSS function that repositions an element along the Z-axis in 3D space. That is, it will bring the element closer or farther away from the viewer. The last question, what is the perspective function in CSS? So the perspective function is used to give a 3D positioned element some perspective. It defines how far the object is away from the user. The transform rotate function is used for rotating the element to a given degree. That is, it rotates the element based on the angle that you provide as an argument. It rotates the element in a two-dimensional space, that is X and Y plane. The rotation is clockwise and starts from 0 degree to 360 degrees. So let's move to a practical implementation. I'm continuing with the code we saw in the previous lecture. I'm giving the rotate function here. Let's say I want to rotate up to 25 degrees. And you can see it rotates the element 25 degrees on X and Y plane. Apart from degrees, you can give radian, gradient, and turn. You can also give negative values with any of these units. So if I give here negative 0.9 turn, then it is absolutely valid. Similarly, we have the rotate X, rotate Y, and rotate Z, which are used for 3D transformation. So let's check these as well. First, let me just comment on this rotate function, and I will add a bottom margin of 100 pixels just to have the clear output look. Also adding left margin of 100 pixels for transform 3D division. Next, let me change the z-axis value to 20 pixels and will give the rotate y to 30 degree. And you can see it rotates the element on the y-axis. Similarly, rotate x, but first I will give 0 degree to rotate y so you can clearly make out how the rotation is performed on the y-axis. And I will give 40 degree to rotate x. You can see that the rotate x rotates the element on the x-axis. And finally, the rotate z 15 degrees. It will rotate the element on the z-axis. Let me set the rotate y value again. And to give all these values together, there is a shorthand called rotate 3D, which takes 4 parameters. Let me give rotate 3D, and I will give the first value for the x-axis as 1. This function takes arguments as numbers instead of length units. The rest is y-axis and z-axis. I will keep them 0, and then the fourth parameter we specify the degree of rotation. I will give 30 degrees. The first 3 parameters specify the rotation direction along which the rotation will help, and together they form a direction vector x, y, z, which is used to apply the rotation. A positive angle value will rotate the element in the clockwise direction along the axis, and a negative value will rotate it in the counterclockwise direction along that axis. So right now, as I have given 1, 0, 0, it's going to rotate the x-axis only. If I give the y-axis value to 1, you can see how the y-axis rotation is performed. Let me give all 3 values. I will give 1, 1, 1, 30 degrees. This rotates the element 30 degrees on the z-axis as well. You can give negative values to perform counterclockwise rotation. Let me give -1 here, and it's going to rotate the y-axis counterclockwise. And yes, the values for rotation should be kept between 0 and 1. So this is how you can rotate any element along the x, y, or z axis plane with the rotate function. So in this lecture, we are going to see an assignment where we are implementing a 90 degrees rotating division, and it will look something like this. So once you finish this exercise, you're going to achieve this result, which you can see right now. You can try on your own, otherwise let's proceed further. So I'll start by defining a main division with the class name as cube. I'm going to create 2 subdivisions inside, naming them as front and back. I'll give the same heading as their class names to both of them. Now let's style the body. I'm giving text transform, uppercase, top padding of 3em and line height 62 pixels. Next, I'll style both the divisions, that is front and back. So let me give background, border. Now let me give height of 200 pixels. Let me also give some width. Next, we want a cube, so let's convert these divisions into a cube shape. I'm giving width 30%, text align to center, top bottom margin to 0, and right and left margin auto. And let me also give height to 200 pixels. Now we have a cube looking structure. Now we want this back division at the back side of the front division. So for that, I will rotate the back division on the x-axis in -90 degrees. And this sends the back division to the back side of the front division. I'll also translate the division to z-axis about -100 pixels to make it come upwards on the z-axis. Otherwise, it will keep appearing below the front division, which we do not want. Now for the front division, I will give the translate Z to 100 pixels to make it appear closer. Let me also give some top padding to H1, 40 pixels would be enough. And I'll set the perspective inside the body as well, let's say 1000 pixels. And finally the hover effect. I want to rotate the cube on hover, so I will give the rotate X to 90 degree to the cube. This will bring the back division to the front on hover. Right now, when I hover on the division, you can see it is flat and the backside is not getting displayed properly. To solve this, I will add a property called Transform Style. This is a newer property which specifies how the elements or nested elements should be displayed in 3D space. We will be seeing this property many times in upcoming examples. Right now, I will keep the value as preserve 3D and will add a transition of 1.55 seconds. And now when I hover on the cube, you can see the front side is going upwards and the back side is displayed in front. So this is how you can use the rotate functions for creating animations like this. As the name says, the scale function is used for scaling the element's size. In simple words, you can alter the element's overall size. The scaling of elements takes place on both the x and y axis plane. Let's look at an example. I have defined divisions and have applied normal styling to it like padding, background, margin, width and height. Let me now apply the scale function on division 1. I will say transform scale x as I want to scale this division on the x-axis. It takes a unitless number value as a parameter. I will give 2 and you can see it increases the size on the x-axis plane. 1 is the default scaling value of any element. Now if I change it to 3, the scaling of element on the x-axis keeps increasing. You can also give negative values. So if I give -3 here, you can see the text is reversed on the x-axis plane, which means the element gets flipped on the x-axis. Similarly, let me give scale y. I will first give the default value 1 to scale x and will set the value for scale y as 2. And now you see this scales the element on the y-axis. If I give -2 here, you can see the text getting reversed on the y-axis plane. That is, the element is flipped on the y-axis. There is also a shorthand which takes both x and y-axis values, and that is the scale function. So let me first give a single value, scale 3, and this will scale the element on both the axes equally. If you want to give separate values for scaling the element on the x and y axis, you give two values separated by comma. So 3 for scaling on x-axis, comma 2.5 for scaling on the y-axis. Now if you want to flip the element on both the axes, you can give negative values to both of them. So this is how the scale function is used for scaling the element on the x and y axis, that is 2D transformation. For three-dimensional scaling of elements, you specify the scale z along with scale x and scale y, or just give the shorthand, that is scale 3D, for specifying all three directions. So let's try that. I'm giving scale 3D function for x-axis. Let me give 2. For y, I'll give 1.5, and for z-axis, I'll give 1. In order to check the result, I will also add the rotate 3D function, as we do not have a 3D cube figure, and giving the perspective as well, 200 pixels. And now you can see the scaling of element on the z-axis as well. If I change the z-axis value to 2, it scales more on the z-axis. Let me again change the z-axis value to 3, and you can now easily make out the result. So scale function will scale the element on x and y axis, that is two-dimensional scaling, and scale 3D function is used for three-dimensional scaling, that is it scales the element on x, y and z axis respectively. Let's talk about the relative question. So what is a scale function? So it defines a transformation that resizes an element on the 2D plane. That is, it will make the element big or small. It resizes the element's horizontal and vertical dimensions on different scales. The skew transform function defines a transformation that skews the element, that is, it bends the element to a specified value as provided inside the parameter list. The transformation is done on a 2D plane, so you will have to specify the x and y axis angled direction. So let's implement it practically. This time let's take an image instead of an element. I will give the source and its alternative text. Let's style it. I'll give margin 110 pixels, width 400 and border. Now let's see what happens when we apply the skew function on it. I will give the transform property. Let's first apply skew on the x-axis. I'll give skew x 10 degrees, and you can see it skews the image horizontally, that is on x-axis. If I change it to 30 degrees, it will skew the image on x-axis 30 degrees. Let me give skew y 20 degrees, and I will make the skew x 0 degrees. And you can see the image skews on the y-axis. If I make it negative, it will skew on the negative y-axis. So skewing basically is kind of taking the opposite sides of an element and pushing or pulling them in different directions based on a given angle. And finally, the shorthand, that is the skew function, which takes two arguments. First value denotes the angle on x-axis and second value denotes the angle on y-axis. If you specify only one value, then it is used for the x-axis only and there will be no skewing on the y-axis. So this is how the skewing of any element or image can be worked out with the skew function. So now let's try an assignment for skew function. Let's see a practical usage. I'm going to define a heading in a span tag. Let's apply style now. For body, I will add few additional styles. I'll display it as grid and will place the content to center, giving the minimum height to 100 VH. Next, the H1, I will give font size 3 rem, color, padding 2 rem and 4 rem, background and transform, rotate, I'll say minus 15 degrees and skew minus 15 degrees. Next, let's style the span. I will give the display as inline block. As you know, span is not a block element. So in order to make the styles work properly on span, we have to convert it to a block element. I will give letter spacing to minus 0.2 rem to make the letters appear closer. And let me apply the text shadow property. Finally, I will add hover on span and I'll give letter spacing to 0 rem and cursor to pointer. Let me also add the transition of 1 second to span, and now when I hover the text, you can see it skews. You can also create a skew effect on the navbar menu or create a skew background design for web pages as well. You may have seen or heard about the matrix. A matrix in math terminology is a set of numbers arranged in rows and columns which form a rectangular array. But in CSS, matrix works differently. The matrix function is used for projecting linear transformations and displaying 3D images on a two-dimensional screen. So the matrix function is used for linear transformations, and the matrix 3D function is used for projecting 3D images. The matrix function integrates all the transform functions into one, that is rotate, scale, translate, and skew. It takes up to 6 parameters, and the syntax goes like this, where you give the matrix and then you give scale x, skew y, skew x, and scale y. You also give the translate x and translate y as well. Let's implement an example to get the clear idea. I'm going to define 3 divisions. The second and third division, I'm giving ID names as my div 1 and 2. Styling the division now, let me give width 300 pixels, font size 1.5 rem, text align, I'll say center, padding 25 pixels, and margin, I'm going to give 20 pixels with some background color and border as well. I will apply the transform matrix on my div 1, so I'll give scale x as 1. If you remember, the scale method resizes the element. Next is skew y and skew x. I will give minus 0.3 and 0. Skew method skews the element, that is, it skews the element on the x and y axis. Next is scale y, I'm giving 1. Then translate x and translate y, so giving 0 and 20 respectively. And we are ready with our first set of values defined inside the matrix. This is what the syntax says. The first 4 values describe the linear transformation a, b, c, and d. And the last 2 values, that is tx and ty, describes the translation of the element to be applied on the x and y axis. So each value represents unique transform function methods. This is what the matrix method is all about, that is, to define all these functions in a single method. Now we will set a 3D transformation for the last division using the matrix 3D function. I will give transform matrix 3D. Now this function is an alternative to all the 3D transform functions like rotate 3D, rotate x, rotate y, rotate z, translate 3D, translate x, translate y, and translate z. Also scale 3D, scale z, and perspective. It takes up to 16 parameters described in column major order, which creates a 4x4 matrix. So let me define the values. The first 12 values are for linear transformation, and the last 4 values are for describing translations. This is what each value specifies. As these values are in column major order, the parameters as matrix elements will look like this. The A1 value describes the scaling on x-axis, A2 for the skew x on z-axis, A3 for skew x on y-axis, and A4 for translate x. Similarly, we have values for B1 to B4, C1 to C4, and D1 to D4. Note that in matrix and matrix 3D functions, the order of values are not in sequence. You will have to remember them as mentioned here. Normally, we do not see the matrix or matrix 3D functions getting used everywhere. Instead, the developers try to keep the code more meaningful by specifying individual functions for 2D or 3D transformations. Even if you know how matrix 3D works, that doesn't mean you'll know what values to provide it every time you do a transform. As you have seen, the numbers can get quite complex, and you will need to be able to calculate each argument in your mind if you expect to use it in the same way you code the other translation functions. But anyways, you can go ahead and see how it works for you, because anytime you define a CSS transform function, you are affecting the matrix. For example, if I comment on this matrix 3D and apply rotate 3D instead, and when I open the DevTools and inspect the division 3 in the computed section, you can see the matrix 3D being displayed. So even with rotate 3D or any other transform function, you are still affecting the matrix, as it determines the coordinates of the element, its size, position, orientation, etc. All these are represented in 16 parameters. Let's talk about questions of what is matrix in CSS. So matrix function is used for creating two-dimensional matrix transformations on the screen. This function integrates all these functions into one. In this lecture, I am taking a 3D card flip design with the help of transform methods we saw up till now. I am also going to use the Bootstrap logos for the card's face. So let's begin. I'm going to define a division with the class name as container, creating a subdivision named card. Now, as you know, a 3D card has two sides, that is front and back. So I will create two more subdivisions named face, face front, and face, face back. I will give the name Facebook here for the back side of the card, as I'm going to display the Facebook's icon on the front side. Also, you may have noticed I'm using a typical naming convention called BEM, that is block element modifier. This naming convention helps you to achieve reusable components and code sharing at the same time. You will further get the idea when we style the elements with these class selectors. For the logo, I will head to the Bootstrap official site and click on the icons button on the navbar, and you can see the various list of icons that Bootstrap offers. I will search the Facebook logo, click the icon, and at the right hand side you can see the SVG path which says copy HTML. I will copy this code and paste it in the front division, changing the width and height to 50 and 35. And you can see the logo is displayed on top of the text. Let's create a few more cards. I'll duplicate the above card division and will remove the SVG path, giving the name as Twitter. I will duplicate this division 3 more times, and I'll change the names to LinkedIn, Instagram, and GitHub. Now for their respective logos, I have already copied the SVG paths from Bootstrap and have set their height and width as well. You can see how the output looks now. First, we have the logo that's going to be at the front of the card, and then the name which will be at the back side of the card. Alright, so we are more or less done with the HTML code. Now let's style the elements. First is the container. I will display it as flex, applying width 100%, height 100 VH, justify content to center, align items, center as well, and perspective 1000 pixels. Let's style the card now. I'll set the position to relative, width to 6 rem, height the same, margin 0.5 rem, text align to center, line height 6 rem, and border radius to 0.8 rem. Next, I'll style the front and back. For front, I will give background and font size 3 rem. For back, let me give background, font size to 1 rem, and transform, rotate Y 180 degrees. So this rotates the text, that is the back side of the card. Now I will style the face, that is both front and back of the card together. So this is why the BEM naming convention is used, as it gives us code reusability and code sharing. So you will not have to write the code for front and back if they share similar code. You can also write like this, but for a quicker approach, you can prefer this one. Alright, let's apply styles to it. I'll set the display as block. Note that they are already displayed as block, but setting this property, I'm certain that the element remains as block no matter what further changes are applied on it. Next, I'll set position as absolute, top and left to 0, width 100%, height also 100%, border radius to 0.8 rem. I want to hide this text, so indirectly it goes behind, and for that I'll use the backface visibility property and keep it hidden. Some browsers don't support the backface visibility property, so we can use WebKit backface visibility property hidden, and this solves the problem. Next, I'll give hover effect to card as well as the front. I'll give transform rotate Y minus 180 degrees. This will send the front to back side when we hover it. Applying second hover effect on card and back of the card, I'll give transform rotate Y 0 degrees. Right now when I hover on it, this looks a bit rigid. Let's fix this by giving some transition. And transform style as preserve-3D to the card. I will hover on the cards, so this gives us the 3D card flip effect.